before we resume to the next section, here is an example of an image that I captured, where an example of light bends towards the normal line. The light reflected when it enters from the air into the glass, and then glass comes out into the air. When you have a very thick glass, what happened? The straw seems to have crooked. It's an illusion. This is not Photoshop, but this is a real image. You know, the same effect, you will able to see it if you insert a straw onto a glass with thick walls. And you see at an angle, this is what happened. See 1, 2, 3, because this glass, it bends, okay? The shape of a glass, okay? It follows the shape of a glass, you see? This is actually a straight straw, but it turns out to be bent. This is kind of an illusion caused by refraction. Okay, now, in this chapter, in terms of objective question, all you need to know is there are actually 4 different types of way to how to calculate the refractive index. Okay, so I think there's an idea what does it mean by reflection now. So next would be called, what does it mean by reflective index? Which are the 4 ways? Okay, reflective index, small n. Okay, in physics you need to learn about this symbol, small n symbol. Okay, so which are the 4 ways of getting the reflective index? But before we go to that, what does it mean by reflective index? It's actually an indication of how light bends, indication of how light ray bends. This is some of the objective question. Bends. Towards the normal line. When it enter the surface from the surface of medium is actually glass sometimes, most of the time it's a glass medium, from air. Okay, so in mathematical form, if your n index number is very high number, 2, 3, 4, 5, very high number, greater the refractive index, meaning it means the light bend. It bends more. Okay, it's a ratio. So one way to calculate refractive index would be, maybe I use one way to calculate refractive index would be by making use of the speed. So initially in my previous video, I calculated how long does it take for light to travel from sun to the earth. It's about 6.5 minutes, isn't it? So the same is true here. All you need to do is you get the speed of light in vacuum. Speed of light in vacuum. It has to be always in vacuum because this is a ratio, bends more, isn't it? So vacuum relative to your medium, to the speed, is always the case. Light at medium, regardless of how the light travel, whether it's from the light from the glass out to the air or air into glass, doesn't really matter how it travels. All you need to do is you use n equals to speed of light, refer to my first video, to the speed of the medium, speed of light at that particular medium, regardless of how it travels. Okay, regardless of the direction. What does it mean by that? Okay, say for example, you have something came into here, normal line, bend towards here. This is the C, this is the V. Okay, what's the speed of this reflected ray and what is the speed of light. All you need to do is use this number to here, put in the number to here. Okay, fine, no problem. But what happened? Sometimes some tricky question, they switch the direction. Okay, now the light enters here, then further apart. Okay, so the angle is different. So this is incident, this is reflected. So all you need to do, again, the same. This is C, this is V. Doesn't really matter where it travels, as long as you use what is the speed at vacuum divided the speed at that particular medium. Doesn't really matter where it travels, whether it travels from the glass out or from the air into the glass. Doesn't really matter. Okay. So for example, say what is the reflecting of perspex. Okay, perspex is like a glass, but it's a plastic glass. Okay, so what we do is you use what's the speed? 3 times 10 power 8 meter per second. This is the speed of light. Doesn't really matter where it travels. And what's the speed when the light is at the perspex? Maybe the tells you is 2.01 times 10 power 8. Okay, this is the speed of light. This is in the question, yeah, objective question. That tells you that the speed of light at perspex is this much. What's the reflective index for perspex? They didn't even never tell you this because you are supposed to know this is a constant. So calculate, and then it is 1.49. Okay. So this is one way to calculate refractive index. Then another way of doing so would be using, this is using speed. Okay. Another way is using angle. Okay. So what we do, n goes to always vacuum over medium. So all you do is use sine theta, where this angle is the angle at vacuum or air. Vacuum or air over sine angle of that medium. Doesn't really matter, okay? Doesn't really matter whether it's a reflective angle or incident angle. Doesn't really matter. It is not about the incident or reflective. All you need to do is take the angle at vacuum divided by the sine of the angle at medium. Doesn't really matter where the rays travel. Okay, so for this case, let's say we'll come back to here. In this case, this is the incident angle, this is the reflective angle. So, and whereas for this case, this is the reflective angle, this is the incident angle. So how do you calculate that? All you have to do, you doesn't need to worry much where it travel. All you need to do is you take the angle at the vacuum here. So you take this angle for this case, whereas here you take this angle. Yeah, this is I, this R. How come you take the same? No, it's not about the reflective or incident. Always student make mistakes. Okay, it is not about the incident or reflective angle. Refractive angle. Okay, not, okay, please take careful, not about that, not, okay, you just take the one here, vacuum, what's the angle here, divided by the medium. This is the medium. Okay, do not care about which one is incident, which one is not incident or reflective. No, it's just take the angle at the vacuum over angle at the medium. Just take it, will do. Don't make your life so hard. Okay, it's very simple physics. Third way of doing so. Now we start with speed, we start with angle. The third one is called distance. Okay, it's kind of a reflection, but I think I will need to sketch a diagram where you have a coin. Okay, you have a coin rest at the beaker. Okay, what happened? Your eye is perpendicular to it, and the coin was seen not so deep. Okay, So what happened? Oh yeah, you have water. Okay. What happened is, now this is the real depth. Always remember the real depth is this, and you've seen the the coin is here, okay, and this one is the apparent depth. Apparent depth. Apparent depth. Okay, symbol is small d perhaps. The real is the real d. Okay, so okay, maybe a line. Okay, it was seen. Okay, here. Okay, enter into an eye. Okay, whereas it's supposed to be here. Okay, so for this kind of case, the refractive index, you have depth. Okay, all you need to do, what is the refractive index? Now your end way to calculate is always the real depth, over the apparent depth. The real one, the real depth meter over the apparent depth. That's all. Where your eye has to be perpendicular. Your eye is, learn this word, perpendicular. Perpendicular. Perpendicular meaning they are 90 degree. Okay, perpendicular to the object. All you need to do is you get the real depth divided by the apparent depth. It's a ratio. Make sure the unit is the same. Yeah, meter divided by meter, cm divided by cm. Okay, there's some reading for this. You maybe want to read on twinkling of a star, or my previous video where you have or beginning of this video we have a bend. Okay, bending of a straw or a ruler in the water. Okay, this is a bend. Okay? It's not actually bend, but it is an illusion. Okay, read on it from a textbook. How does it occur? Right. So these are the third way, and then the fourth way. The fourth way of getting the refractive index is pretty much like the second way, but now we could introduce a new theory, not theory, it's new phenomenon. What it is called, this theory is called total internal reflection. Total internal reflection. Okay, what does it mean by that? Okay, what does it mean by that? Now it means the light band says this day we have what fiber optic technology, etc. So let's look at it. You have fiber optic is a tube. Yeah, this is a tube. This is fiber optic wire. Or not, it's not wire, fiber tube type of optic fiber optic. It's a fiber, solid fiber. Okay, unlike a hose, water hose is a tube, right? Inside is hollow, whereas this is fiber optic, is inside is filled with fiber. Now what happened is, you have a new law. Actually, it's not a law. Is what happened when the light beam of angle of incident exceeded. Say for example, you have a light go in here, incident light. When the angle, remember about normal light. What happened when the angle of incident, exceeded the critical angle. Now critical angle here in light is called an angle where the reflective angle is 90 degrees. Okay, I will talk about it later. When the incident angle exceeded the critical angle, what happened? It will be reflected. Okay, giving you a same reflection. That's why it's called reflection. Okay. Now this is a very special case because here, when you travel from a dense, this is a denser. Okay, this is a dense, because inside a fiber is dense, air is less dense. Travel from dense to less dense, and it exceeded the critical angle. It won't goes out. It won't be reflected, but it will be reflection. You have total internal reflection. Okay. Now, when this case happened, the fourth way of calculating refractive index n would be 1 over sine. This is critical angle C. This is called angle. I know you are not following now because I still haven't defined it. Okay, so that's the fourth way. Total reflection, critical angle. You have critical angle, straight away you get reflective index. Just bear with me now. Next, I'm going to show you what does it mean by the total internal reflection. So there are four ways. One way is use speed. Second way is use angle, vacuum to medium. Third way is use real over apparent depth. The fourth way is make use of critical angle 1 over sine theta. Either it's in radian or in angle degree. Be sure you set your calculator to take number as in radian or in angle. So now, what does it mean by total internal reflection? Here, you have a block. I have a glass block. Okay, I have a glass block. This is a glass. It's in 3D lah. Okay, glass block in 3 dimension. Okay, maybe I draw it. Okay, extend it. Okay, it's continuous, so maybe cut it off. Okay, cut it off. Okay, the glass block. What happened? Okay, glass block. One part of glass block. What happened? Now, if I were to have a ray not from outside, from this plane itself, I have a ray travel from within here, hit on to this surface. What happened is, when the angle, if you still remember, we have this normal line. What happened when the angle, you tilt this angle of ray until this incident ray inside the glass. When this incident, you tilt it, okay, away from it. Maybe you tilt around away from it. What happened? The ray will not come down here, but instead it will go out to here, forming a 90-degree from the normal line. When this happened, your incident angle is called critical angle. This is a time where you have critical angle, where the light from the dense to less dense. Please take note, the light ray travel from a dense region to an optical denser medium to a less dense medium, and the angle of exit is at 90 degree. So now this angle is called critical angle, or C. Okay, so this angle, okay, 90 degree. So how do you get this equation? Is actually, the second way, n is sine at the angle, always doesn't really matter where it travels, it's always at the vacuum is 90 degree, over sine, this is the angle where you have defined as critical angle or incident. Okay, sine 90 is 1, therefore n is 1 over sine theta c. So this is meant by critical angle. Alright, then you may go through those questions now, because from now you should be able to answer quite a lot of objective questions. You need to go through those chapter by chapter questions, where whenever you have total interior reflection, what happens when your angle is more than critical angle. Say for example the angle here is 42 degree for glass. When you reach 40 degree, then the exit ray will be 90 degree. So when your angle is 45, what happens? Then you will be reflected. Okay, you will be bantu balik. Okay, here it's 90 degree when it's critical angle, but when it's more than 42, let's say 45, then it will be reflected internally. That's why it's a total internal reflection that you have in fiber optic. Now you need to read on this on total internal reflection more if you don't get what does it mean. But the concept is always when the angle in the denser or medium, the angle from the normal greater than the critical angle, then the ray will be reflected. Instead of refract, it will be reflected. It will be bounced back. It will be bounced if it's more than critical angle. When it's at critical angle, then the reflection will be at 90 degree. The reflection angle will be 90. Okay. You may pause this video, go back to the previous minute, and listen to what I have said earlier. Okay, so this is the fourth way to get refractive index. Then go through those exercises. You need to about 20 to 30 questions. If one is not enough, get 2 books from different publisher. Most of the time is you have confused about this angle. It's always the vacuum or the air. It's always the air to the medium. Doesn't really matter where it travel. Okay, so maybe I'll give you one more example before we end this video. In your questions, most of the time they use prism. Okay, or they make use of a mathematics, look for angle. Okay, so here prism angle. Okay, say you have an object look like this. One good example of total internal reflection would be okay, right angle prism. So here is 90 degree, and the length here is the same. So what happened is this is 45 degree and 45 degree. Now, when light travels perpendicular from this surface into here, this is normal line. When the light is normal to the surface, what happened? You need to apply normal line. So here is a boundary, glass, air, so you have a normal line, right? So this is a normal. Always don't forget about your normal. So what happened? Now, when this is 90 degree, this is 45, here is also 45. And then, would it goes out or goes in? Now, here the interesting question, because now it's 45, this is 45, this is also 45. Knowing that the critical angle for glass is 42, happened is, now this is 45. So here 45, this is 45. Therefore, it will be reflected. Reflection goes out. Okay, it will not go out here, but reflected. Where the angle here should be the same as here. The critical angle for glass 42, when it is 45, then you have internal reflection, total internal reflection. Alright, and then another example, perhaps. I have a block, glass block. What happened? Incident ray. Maybe I use I. Okay. This is a normal line, not even 90 degree. Oh my gosh. Oh. Okay. Try to be perfect. Okay. This is my normal line. Say this is my incident ray. And then it goes into here. And then surprisingly it doesn't goes out, it doesn't reflect, but it goes this way out. Right? And the angle, they give you angle here to here is 140 degree. Right? Then you thought you can't solve it. What is the refractive index? From this point, no other physics, because it's all about maths. If you get the concept right, the others is all about mathematics. Because why? Now, say for example, now you need to identify your problem. So it's 140 degree. We do not measure angle from the surface or boundary, but from normal. So you need to construct a normal line here, where normal line is always 90 degree. So obviously the angle from the normal here is 50 degree. You get one information. Right? So if the incident angle 50, here is obviously 90, easily you will be able to tell the refractive index, n would be always the sine vacuum over the sine medium, or in this case 90 degree, this is called critical angle, 50 degrees critical angle. So therefore how do I know it's critical angle? Because the exit ray is 90 degree. When it's 90 degree, so therefore this angle is called critical angle. So therefore my n would be 1 over sine 50. So therefore your n would be 1.31. You get the answer. Okay, you need to resolve them. Yeah, you cannot just straight away. Always remember, angle always measure from the normal. You need to construct your normal line. Okay, then of course I can ask what's the angle of incident, right? And from there you solve here, and then you know the refractive index, and then you solve the signs. Okay. So say for example here 90, here 90, 50, eventually here it will be 40 degree. I mean, it's theorem Pythagoras, right? So what you do, how do you get what is the incident angle? Okay, how to do that? Now n is, you found this already, so it's 1.31, where in this case first case, you may use sine theta vacuum over sine, I've stated over right hand side. I've stated here. So now you have the vacuum, you need to find out. You have the medium angle. So all you need to do, your sine theta in the vacuum or the air is therefore your n times your sine theta in the medium, which is 1.31 sine medium is 40. Yeah, you should be able to find out this angle. Okay, otherwise you can't solve it. Okay, so therefore you add sines it, vacuum or incident, therefore would be somewhere around 57 degree. Right? Okay, these are the example, okay, of possible objective question. Okay, now you really need to read on the textbook found in the market. You get any publisher will do. I'll summarize what you need to know for this chapter for calculation part, the four-way, the total integral fraction, etc. All I need to ask from you is you need to go through those exercise, chapter by chapter exercise. You must have at least 30 questions. You have done it yourself. Maybe you look through a reference on how to solve it, okay, learn up the way how to solve it, and then you solve it yourself. At least 30 questions over a week time. In a week time, you are supposed to solve 30 questions regarding what I've discussed in this video, otherwise it's useless. Yeah? Well, that's all from me. My next video will be on the mirror and lenses. Okay? I hope you like this video. Share it with your friends through a social network, Facebook, etc., Twitter, etc. And press on thumbs up button if it's good. It really inspires me. And subscribe to my channel for more upcoming video. Thank you.